Welcome back to our companion series for Khan Academy. It's your host, Mr. Coley. I don't want to scare you today, but today we're going to talk about math. Okay. So far, we've talked about what is programming, about the idea of pseudocode being kind of a general shorthand language for multiple different languages to kind of reference to, and pseudocode kind of has its own standards. We're going to see a little bit more of that today, but the idea of it being the easiest, almost what you call it, like the least common denominator in all of the different languages, so that if you're sitting down with other people who don't speak the same programming language as you can try to come up with a working pseudocode that you can then all go out your own way and write it in your own languages. Then we talked about storing data and variables. And variables are very interesting. How we use the print line function to be able to see them. We could store numbers. Sometimes the user inputs some numbers. Sometimes the ROM stores, like your saved progress in a video game. How variables are used. Today, we're going to talk about math. And math was my worst subject in school. But I'm not really asking you to do any math. I just need you to know how programming works with math. So let's dive right in. Okay? So when we talk about math here, we're talking about mathematical expressions. We're kind of talking about how the programming is used kind of to do the calculations, of course. So how do we get the computer to do the math for us? Well, first we are going to have a refresher on some of these things that we've been doing since kindergarten. Arithmetic operators. Now, that's just things like addition, subtraction, multiplication, and division. And we also have these things called remainders, which I haven't used in a long time, but if we say how many times does 10 go into 13, we'd say it goes in there once with a remainder of 3. That's how we used to say it. In JavaScript, these symbols right here are important. These operators, the plus sign, the negative sign, maybe a star, the backslash or forward slash, and the percentage sign. Okay. What's convenient for me is that on my keyboard that I'm using right now, on the right-hand side where they have the number pad, I'm surrounded by a slash, a multiplication, a negative, and an addition. So everything but the remainder is right at the right-hand side. Of course, you could do it in the number line of the keyboard if you hit Shift and, whatever you need. But it's nice and convenient that they're located on the right-hand side of the keyboard. And many of those look super familiar to you. You use them in math class. Most of you have never seen this, the remainder operator. And here's an explanation of how it works. The expression 10 remainder 3 calculates the remainder of 10 divided by 3. The result is 1. Since 10 is divided by 3 equals 3 and leaves a remainder of 1. So if you're just looking to see what's the remainder, okay, you're not asking what's the answer plus remainder, but if you just need to see how many's left over, you would type in 10. You're saying, the question really is how many times does 3 go into 10, and what's left over if I put 3 into 10? So 10 divided by 3 is 3, and a remainder of 1. The remainder operator is also called the modulo operator. So typically read the 10 remainder 3 as 10 mod 3. This mod is important, and you're going to see it in the pseudocode. So mod is important. All right, the rest of them we pretty much know about. We can make longer expressions like this one that calculates the number of minutes in a year. 60 minutes times 24 hours times 365 days. We can also combine different operators in the same expression, like this one that converts the temperature of 77 Fahrenheit to Celsius. Now, apparently this is how you convert. This was my 77 I don't know enough about this to be honest, but like I think 32 is freezing. I don't know if that's why we do it. I'll need a math check on this. Times 5/9. So apparently, if you take the current Fahrenheit, subtract 32, and times that by 5/9, that'll give you the Celsius reading. Okay. When an expression involves different operators, JavaScript follows an order of operations for deciding what operations to evaluate first, like multiplying before subtracting. However, it's best to use parentheses to make the order obvious and reduce the likelihood of making a mistake. Okay, experiment with the arithmetic operators in this program. So, if I what it's doing is says print the line, and then it gives you the operators inside of the parentheses. So 33, print the line of 33 plus 67. 33 plus 67 is 100. Print the line or the answer to the following. 1024 minus 256 is 768. 12 times 12 is 144. 144 times 12 is also 12. 10 remainder 2, or 10 mod 2. Remember, this symbol right here, you should really start thinking about it as mod or modulo operator. The question it's really asking is, how many is left over if I take 10 and take as many 2's out of 10? So we know that 10 divided by 2 is 5, and there's nothing left over. So the answer is 0. 60 times 24 times 365 is 520. Actually, we know that from the hit musical Rent. 525,600 minutes. How do you measure a year? If you don't know that song, YouTube it. And finally, this is what it was saying, I think, like right here. It's often best to use parentheses to make the order obvious and reduce the likelihood. This is saying, notice there's an outside parenthesis, an inside parenthesis. 77 minus 32 times 5/9 parenthesis. So we want it to do this number first. So in math, I do remember this. Order of operations, please excuse my dear Aunt Sally. Parentheses, exponents, multiply, divide, add, subtract, right? So first thing we want to do is parentheses. That's why we add them. If we left the parentheses off, okay, no parentheses, then it would be 32 times 5/9, and then 77 minus whatever that answer was. That's not what we want. We're telling it is we need the answer of this, and then we want that answer with the parentheses to be taken times 5/9. So this is just a matter of clearing things up. Okay. And now we're going to move down to storing with variables. We'll often want to store the results of mathematical expressions in variables, especially if we want to reuse the results of a calculation later. This line of JavaScript stores the number of milliseconds in an hour. Okay, so we got a variable. We'll give it a name, hours ms. So like milliseconds in an hour, right? We're going to talk about naming, I think, a little later, but the capitalizing, not the first word, but the second and third word are important. But let's not worry about that right now. So we're saying, here's a variable. Its name is hours ms, and that's equal to, and then we've got actually an expression here, 1,000 times 60 times 60. So they're so 1,000 milliseconds times 1 minute times 1 hour, and that would give you a number. Okay. Once this line runs, the variable stores a value of 3,600,000, and it will reference that later on. Okay. If you didn't know that this number right here is how many milliseconds is, but you could logically think it out. Then as you're writing your code, you could just, I need a variable, here's what it's called, and I know if I take 1,000 milliseconds times 1 minute times an hour, that would give me the number. We can also use variables inside mathematical expressions, as long as those variables store numbers. Okay. This code calculates the flour needed to bake 2 loaves of bread. So let's think this through. I have a variable, and it's called number of loaves, and that's equal to 2. Now, I need a variable called total flour cups. So I'm trying to figure out how much flour in there. So total flour cups is equal to the number of loaves times 4. So apparently there's 4 cups of flour for every loaf. And so what we're doing is we're saying no matter how many number of loaves there are, take that times 4. That would give us the total cups of flour. Okay, so when it looks up to see the value is stored as number 2, and then happily calculates 2 times 4, the final result of 8 in total cups of flour. So it's just thinking logically. Remember, everything has to build up to scaffold up to a higher level so that we can do more difficult things. Okay, so instead of just sitting here and putting in the number, which would have been my forte back in the day, I would just done the number and just plugged in the number 8. No, that is actually cheating the computer of doing some of its work of thinking. So we put it in there like this, number of loaves times 4. Because if we ever want to change this number, if we want to, maybe we want to find the number, how much flour is in 100 cups, all we got to do then is change this number to 100 and it would give us the answer. So it's not about us being able to figure it out. It's about programming a software to be able to execute what we want it to do in a fast and efficient manner. Okay. I think we've talked before in class about there's a difference between effective and efficient. I can effectively do the math here to figure out how much flour is needed. But using the program is so much more efficient. Okay, it's easy when the numbers are ones and zeros, but if I open up a donut shop and start baking thousands of loaves of bread, that number's not going to be easier, and that's why we're putting the power of the computer to work. Okay, we're going to look at a program here that calculates the daily range of calories for my cat. The final min-cal and max-cal expressions operate on variables, entirely on variables. So let's walk through this and try to figure it out together. So we've got a variable. It's called cat weight, and that's 15 pounds. So the cat weighs 15 pounds. We've got a variable. It's called the minimum cal per pound. It's 25. We've got a variable. It's called the maximum cal per pound. Now, I'm looking for the minimum cal and the maximum cal. So here we go. Variable min cal is equal to the cat's weight times the minimum calorie per pound. So instead of typing 15 times 25, we would just write out the names of these variables. Cat weight times min cal per pound. We also want, so that's the low end. We also want to see the high end. A variable, max cal, equals cal weight times max cal per pound. So cat weight is this one variable. It's going to reference it in memory, whatever it's set to, of course, whatever it's equal to. And max cal per pound is this one, whatever it's referencing. Okay. So that's great. But if we don't do the rest of these lines, one moment. If we stopped right there, that's awesome, but we wouldn't see it in the program. So I just simply cut those out. Now I'm going to paste those back in. First line, we want it to say print line. My cat needs at least. Print line, minimum cal. So it's coming up here and referencing minimum cal. And it does the calculation for you. So it'll be cat weight 15 times min cal per pound. min calorie per pound 25. 15 times 25 apparently is 375. And then we tell it, but not more than, print line max cal. And remember, max cal is cat weight 15 times min cal per pound, which is 35, which apparently is 525. So there's this was 9 steps written out. Okay. But what's lovely is that maybe my cat gets fat in the future and it gets up to 30 pounds. Well, all I gotta do is change its weight, which is the main variable, that's not the right word, the main things that might change in real life, and the program still works. Isn't that awesome? Okay, we're going to take a look now at the pseudocode for math, which is very easy. It's pretty much exactly the same. For one brief thing, JavaScript used plus, minus, star, and division. Okay, we're good with that. The only thing that's a little different is how we do the remainder. And this is where I told you that mod would come into place. What was that name of that? That was called... the remainder operator is called the modulo operator. Okay, that's where the root word of this comes from. So if you're writing it out in pseudocode, you'd say A mod B. It evaluates the remainder when A is divided by B, assumes that A and B are positive. So that pseudocode is very straightforward. Lucky for us. Now, that was a lot, but it makes a lot of sense if you just take it one step at a time. And remember, I'm not really asking you to do the crazy math. I just want you to know that you can build a program to do the crazy math if you can think it through and tell the computer to do it. Now, one moment. With just the basic arithmetic operators, we can write programs to compute anything a simple calculator can compute. Okay? But what about equaling the scientific calculator with ability of calculate sines, exponent, and logs? Programming languages often provide built-in procedures and constants for such mathematical functionality. That's good news. So, again, don't freak out. I'm not going to ask you to do all this math. I'm going to tell you that the computer can do it, and I'm going to help you access how it does it. So let's start with the simplest example of calculating the absolute value of a number. In JavaScript, we can use the built-in procedure math.abs and then your parentheses and colon. Okay? I don't think that's right. The colon here is to list this down here. So variable abs1, absolute 1. Okay, so here's a variable. This is its name. We're setting it equal to this built-in procedure of absolute value, math.abs, and then insert a -5. And then we're telling it print line math.abs, parentheses -5. Okay. We pass a single parameter to the command, the number to process, and the command returns the absolute variable of that number. We can either store that result in a variable or we can display it on the screen. So if we need to store this for something, we would just create a variable. If we just wanted to print it, we would just simply say print line and then math.abs, which is the built-in procedure for absolute value. And then here's the value we're looking for, -5. Okay. Of course, it's not very exciting that we can calculate the absolute value of a -5. We already know it's 5. I'm glad somebody knew it because I didn't really know what they were talking about. What's exciting is that we can pass in any expression to that procedure and will calculate it itself. All right, good news. So if you have to find the absolute value of a bunch of numbers, but in order to find that number, you have to, we have to multiply, we have to subtract in a certain order. Okay, the result is 13.5. I'm happy I asked the computer to do that one for me. Okay, so all it's telling you is that you can use math.abs to give you the absolute value of whatever it is set of numbers you put in there. That's wonderful. Now, JavaScript language provides 36 built-in math procedures. Here are some you'd like to use in programs, okay? And I'm not going to go through these right now. I'd like you to read through them. But here's what's neat. I'm going to open this in a new, what do you call it, tab. And this is JavaScript reference stuff, okay? When I said earlier in an earlier video about having a cheat sheet, you have a massive cheat sheet. It's called the JavaScript reference. And this is all the built-in objects in math. And so if you're not expected to memorize these, but if you find yourself working in a heavily math area of programming, you absolutely could come here and use these built-in things. There was an example here of converting between degrees and radians, and it says, here's your trig functions. Since humans tend to think in degrees, and some functions such as CSS transform accept degrees, it's a good idea to be able to convert. And so there's a function, degree to rad, degrees, okay, blah, blah, blah. So I just want you to know it's out there, and you can print those off if you ever needed them. So let's take a second. Sorry to be so jumpy. So let's go through just a couple of these, okay? Math.abs, we know that's absolute value. And negative 32, print line, what's the difference? Okay, here's what's different. Okay. Print line and the parentheses, okay, that's the whole variable written out. And these, they left out the parentheses, and it only prints the value, not the variable, just the value. So that's what it's doing. It's doing, so 3 and 4 are the same thing, or the same like math work, but instead it's displaying the first one, which is line 3. It's displaying with parentheses, so it wants to show you all the variable. And the second one, it only cares about the value, okay? Math constants. The field of math includes a number of special numbers. The most famous is probably pi. That's what this symbol is, since it pops up in all things circular. If you've memorized the first dozen digits of pi, then you can go ahead and type that in your programs. For the rest of us mere mortals, we can rely on program language to memorize those for us. I know pi is like 3.14 is all I could ever remember. Okay? So this is more stuff that's just built in and baked right into the language that we don't have to memorize. But if we're up and we know we need it, hey, we just got to reference it. So in JavaScript, we can get an approximate value of pi by referencing math.pi, a variable that's already defined. And I don't know if I've said it yet, but with these, we're using all capitals for this was ABS, this is pi, so capital PI, a variable that's already defined. For example, this expression calculates the circumference with a radius of 12. So there's a variable. Its name is circumference, and it equals 2 times math.pi. So this is the number of pi times 12. The math.pi is a constant, which means it can't be reassigned. We can trust our math more. We know pi will always be pi. You can, okay, here's that math. I don't know if this is a different math reference. No, same thing. There's your reference sheet. All it's doing is pointing you to say, hey, you can check out all these. All right. And we're just going to look at this a little bit. Sorry about the scrolling. It's a little jumpy. Which pizza is a better deal? Okay. Now, the slashes doesn't mean it's not going to represent anything. That's just kind of a text. Okay, so the first variable, a medium pizza radius equals 6. Medium pizza cost equals $15.99. There's a medium pizza area equals math pi. So, and then it does out the work here for us. I don't care about the math. You can figure out the math. If you're going to go into a math field, fantastic. But I don't care about the math, honestly, because I'm not good at it. All you need to know is that for this lesson, there are procedures and constants built right into JavaScript like this right here. Instead of typing out 3.14 whatever, they type math.py. And that references something in the index of JavaScript that's baked down deep into the program. It says, hey, go get that number you've already stored because you've already got it. And you can find those numbers on these reference sheets. Okay. Math in pseudocode. In pseudocode, you'll likely see built-in mathematical procedures like this. ABS number means return the absolute value of a number. Okay. Back to the pseudocode can be this: ABS1, arrow, ABS -5. Display, ABS -5. In pseudocode, constants are written in all caps, like the constant pi. An expression to calculate will be written like this: circumference, arrow 2, times pi times radius. Notice radius and circumference are not capitalized. Pi is capitalized because it's one of those constants. Pseudocode can get a little bit confusing. You just look for the commonalities, and that's good. Okay, that's it for this lesson. Okay, I didn't want to get into strings. I'm going to make its own video. So that is mathematical expressions, procedures, and constants.